All right, let's talk about CRCT Review 1 and 2. We'll start with 1, of course. Ernie walks. Here, let me blow up the view on it. Might help you see it just a touch. Put it at $1.50. And if you can't really see that too well, just follow along with your paper. My numbers won't quite jive up to yours, but they'll be close. Ernie walks 1/6 of a mile in 1/12 of an hour when he walks along the river trail. How many miles per hour does Ernie walk when he hikes on that trail? Miles per hour is what we would call a unit rate. And anytime we're dealing with unit rate, we're going to put something over, if we have time, we're going to put something over time. In this case, it's going to be distance over time. So always remember, if you're looking for the unit rate, you're going to put distance over time. And in this case, we're going to have 1/6 over 1/12. Mr. Camp, I don't understand what that means. I've never really, that's not very familiar to me. All that means is 1/6 divided by 1/12. And keep in mind, nobody talks like this, but they're just trying to get you to understand what operations to perform and in what order to perform them in. If you're having a hard time with this, all you need to do is go back in here and make something more reasonable to teach you what operation to perform and in what order to do it. So you can say Ernie walks 3 miles in 1 hour or something like that. You would divide 3 by 1 and you'd go from there. Well, we don't have that. We do have this, however. We do have 1/6 of a mile in 1/12 of an hour. We simply divide here. We would say 1/6 divided by 1/12. But when we divide fractions like this, we keep, change, and flip. We would say 1/6 times 12/1 for 12/6, because we multiply straight across here. And this is 2. Oops, sorry. If you take a look at those answers, this is what you'll get if you multiply these two together. 1/72 of a mile an hour is pretty slow. That's like a snail. Okay. Number 2, a picture would really benefit you here. But if you want to just do it mathematically, you can. You can draw yourself a picture of the water surface here and a submarine down here, and say this guy is negative 35 feet, and we want to know if he rose 35 feet, which indicates addition, where would he be? Well, we can visualize it. See here, if we move up 35 feet, we'll be at 0 elevation. We can do that, and hopefully your picture will be a little bit neater than mine, but I'm in a hurry. Or you can simply write it out algebraically or mathematically. A submarine is at an elevation of negative 35 feet. Then he rises 35 feet. Rises indicates addition. So we have negative 35 plus 35. And if you completely lose your mind and forget exactly what to do, you can say, well, this is an addition problem. We can say same signs add and keep, different signs subtract. So since we have different signs here, we're going to say 35. Same signs add and keep, different signs subtract. Oops, sorry, that's 35. And we get 0. We don't have to worry about whether or not it's positive or negative, because 0 is neither one. Okay. The answer is B. A map has a scale of 1/2 inch equals 16 miles. The distance between 2 parks on a map is 2 3/4 inches. How many miles apart are the parks? This is one where we have to set up a proportion, and we need to label that proportion. That way we know exactly where everything is and where everything goes. If you do that, it's impossible to get them wrong unless you just mess up on the math somewhere. So we're going to do our scale first, and then our actual. And when I say actual, what I mean is what's actually on the map and what is actual on the territory that it represents. And we're dealing with inches and miles. You should always put inches over miles of the small unit over on top of the big unit. And if you label this, you know exactly where everything goes. Let's talk about our scale first. We have 1/2 inch over 16 miles. Now that we've labeled this inches and miles, we know where that goes. It has to go with inches. 2 and 3/4 over x, because we don't know what it represents, and that's what we're trying to do here. This is a situation where you could try to fill in these answers to see. I'm going to go ahead and do it the long way, but listen, and this is, for the parents listening also, I don't teach these methods, these shortcut methods all year, but now we're at crunch time, we're at CRCT time. There's nothing wrong with it if you can't figure out a problem on your own to try to back into it or try to fill in the blanks and see which one works. If you do fill in these and you reduce them, you will see that one of those is a proportional relationship. But anyway, what I'm going to do, I'm going to go ahead and convert these to fractions, decimals, and then cross multiply. So now I've got 0.5, and I told you to memorize some of your easier fractions a long time ago, and this is 2.75 over x. Now another tip you could do, if you ever get a half mile like that, you could always double both of them. You'll have 1 over 32 if you want to do that way. I'm going to go ahead and do it the old-fashioned way and say we're going to cross multiply and have 0.5 x equals, and 16 times 2.75, just take my word for it, is 44. Okay. Well, now I'm going to divide both sides, not by 5, but by 0.5. I saw a lot of people making this mistake, so you've got to be careful. This is going to cancel out, and you're going to have 44 divided by 0.5. You would move your decimal over here, and this is 88, which is D. Number 4. A number cube labeled 1 through 6 is rolled 450 times. Which is the best prediction for the number of times that the number cube will land on a number less than 3? Well, first of all, we got to figure out what is the probability of rolling less than 3, and then make a proportion and compare that to 450. So what do I mean by that? What is the probability that you'll get something less than 3? Keep in mind that doesn't count 3. 3 does not count in that. If I said 3 or less, it would. And it would be 1/2. But I'm saying less than 3. The only two numbers on a number cube less than 3 are 1 and 2. So if you have 2 possibilities, or 2 things that you like, and 6 possibilities, your probability is going to be 2 over 6. And you can reduce that to 1 over 3 if you want to. And what this also means is if I roll a die 6 times, what that means is I can expect to get a number less than 3 twice. Well, if I know that's my theoretical probability, I can also figure out about how many times it would happen if I rolled it 450 times. And that's how we set that one up. Okay. Now I'm going to go ahead and reduce this to 1/3 because it makes it easier. We're going to have 3x equals 450. We can divide both sides by 3. And this is going to leave me with 150. Just take my word for it. I'll let you figure out the math on that. Now also, if you reduce it and you have an easy probability like 1/3, you can also take a look at the answers and see which one. Look, how do I get from 1 to 3? I multiply by 3. Well, what would I have to multiply by 3 to get 450? And the answer is fairly simple at 150. Now we have a judgment call to make. We've got 150, but there are 2 150s. One says about 150. One says exactly. And it says, which is the best prediction for the number of times that the number cube will land on a number less than 3? The answer is going to be A, about 150 times. Because if we do this 450 times, I can almost guarantee you that it's not going to be exactly 150. It's going to be very close. It might be 151, 152, 148, 149, and so on. But remember, our theoretical probability and our experimental probability are sometimes different. Okay, so don't forget that. The answer here is going to be about 150 times because we can't make a hard and sure prediction. Okay? Number 5. Which is equivalent? You may see several of these. You may see several of these on the CRCT. What happens here? You need to look at the answers first. A problem like this has been simplified and then factored. It has been simplified and then factored. What I mean by simplified is you got to combine like terms. And you must pay attention to the signs that are in front of the numbers to tell you whether or not you're going to be going positive or negative. 6x plus 2x, because those have the same variable, and remember you cannot combine terms adding or subtracting with terms that don't have the same variable. This is going to be 8x, this is done and this is done, a positive y plus a 3y, and you have to pretend there's a 1 in front of that y, is going to be positive 4y. Well, none of those choices are here. It hasn't been factored yet. And what factoring is you're going to pull out, if you will, the highest number that will go into both of these. Well, Mr. Kemp, 2 will go into both of these. Yes, you're right. You can factor out a 2, but that's not the highest number that will go into both of those. The highest number that will go into both of those is actually 4. So that number will go on the outside of the parentheses, and we have a parentheses here. Ask yourself, how many times will 4 go into 8x? It will go in there 2x times. You do the math with the coefficient here and leave the variable. How many times will 4 go into 4y? A positive 1y times, or just y, because we leave the 1 off if it's just 1. And here we have our answer, which is B. Okay. He had generated a list of random numbers to simulate an experiment based on the waiting times at a supermarket checkout line. The number 1 represents waiting in line less than 5 minutes, and the number 2 represents the waiting in line 5 or more minutes. So you got a bunch of 1s and a bunch of 2s here. Well, if you count out, you've got a total of 25. And 14 times we got 1, which means 5 or less. And forgive my handwriting here. And then 11 times for 5 or more minutes. So what we have to do is, and it says, what conclusion can Tia most reasonably draw from the simulation? A person is likely to wait in line less than 5 minutes, which is this side right here, 14% of the time. This is what we call a trap answer right here, because you're going to look at that 14 and say, well, that's 14%. Well, no, that is not 14%. 14% would be 14 out of 100. And here we have 14 out of 25, so that is not a percentage. If you look at that, that's about 56%. And this would be about 44%. Okay. B, a person is likely to wait in line 5 minutes or more 11% of the time. That would look correct also, but that's not 11%. That's 11 out of 25. And for it to be 11%, it would have to be 11 out of 100. C, a person is likely to wait in line less than 5 minutes more than 50% of the time. Is 14 more than half or half of 25? Yeah, you bet. It looks like we might have an answer there, but we need to go ahead and read all the choices just to make sure. D, a person is likely to wait in line 5 minutes or more 50% of the time. No, this is definitely not 50%. 11 is definitely less than half of 25. So it looks like we have an answer. Let's see. This is one of those situations, that last question right there, you really need to read the question thoroughly. You will have plenty of time on the CRCT. You need to make sure you read the questions thoroughly and all the answers before you make a snap decision. This is another one where you can make a very, very easy mistake. A lot of people are putting 12 over 16 for the probability of picking a girl. Well, what's wrong with that is there are 16 boys, not a total of 16. Right here, our probability for this question is 12 over 28. Because we have to add the total of the two together. There are 12 girls and 16 boys in diving class. If one of them is selected randomly, what's the probability that it's a girl? So this is not the probability that this is. Forgive me. I hope I haven't done that too much in the video. I'll move toward the middle now. 12 out of 28. Okay. Well, this obviously reduces to 6 over 14, which reduces to 3 over 7. 3 over 7. 8. A circular garden has a diameter of 6 feet. Which of the following is closest to the area? If you remember, and you'll have these formulas on the CRCT, most of them. Formula for area is pi r squared, which is 3.14 times the radius squared. Well, what is our radius? It only gives us the diameter. By definition, our radius is going to be half of the diameter, so this is going to be times 3. squared. So we're going to be 3.14 times 9. And 3.14 times 9, just take my word for it, is B. 28.26 square feet. Again, I haven't taught you this way all year. What you would normally do with this one is come up with a two-step equation, and this is actually an inequality. I didn't teach it to you this way, but this is an inequality where you would say 12B for the number of bikes sold plus 200 for the amount he made every month equals 400. And what we've got to figure out is the least number that can go here to give us our $400 a month. Jerome earns $200 a month plus $12 for each bike he sells at the bike shop. This month he wants to earn at least 400 bucks. What is the least number of bikes Jerome can sell? Now, you can do this the old-fashioned way, the way I taught you, and subtract 200 from here, from both sides. You can have 12B equals 200. Divide both sides by 12, and you get 16.6. I'll let you work the math out on that. And that's going to round up because if we sell 16 bikes and we put that in here, we make about $392. That's not enough for 400. So we have to, and we're not really rounding, we're just thinking, if you will. It's 17 because we have to sell the 17th bike. Okay? Now you can do it this way, and again, I've taught you this all year. And I don't recommend shortcuts as a matter of teaching math, but I will tell you this. If you get stumped on this and you cannot do it, try every one of these numbers. First you can say 15 times 12, which is 180, plus my $200 a month equals 380. That's not enough because we got to have 400. Okay? Then you would try it with 16. You would try it with 17. And then when you get to 17, you understand. And keep in mind, you've got to be careful. This question is asking us, what is the least number of bikes? Okay? Because 33 works, but I asked the least number. Okay? So please be careful with that. Number 10, how is 4 and 3/11ths written as a decimal number? 4, all we do, we leave that alone. Okay? We don't have to mess with that at all. All we do, the top dog is going to go in the house for the decimal equivalent. We're going to say 3 divided by 11. And I'm going to let you deal with the math on this, but it comes out to 272727. Our answer is A, because our 27 begins to repeat. If you see it repeat once, you can assume that it's repeating, at least for while you're in 7th grade. Okay? And keep in mind, this is not the right answer. This is a trap, everybody. All right, because people get out to 272, they get tired, like, oh, well, that's the answer. No, the answer is A. And keep in mind, that line means that the 27 is repeating. This is 27, 27, 27, 27, and so on. This line, this one's just over the 6. So the 36 is not repeating, but the 6 is. So don't forget that, okay? Now let's move on, and hopefully I'll get to do most of these on the second worksheet as well. Which of the following equations represents a proportional relationship? All you have to do on this one is cross multiply, and if you get the same answer, you're golden. You can also reduce to figure out if you've got the same proportional relationship. If you have a proportional relationship, that means that the fractions equal, okay? I can eliminate, oh, actually I can't. Let's see. 3 times 12 is 36. 2 times 15 is 30. So no, that doesn't work. Okay. Let's see. This one's not, because I know those aren't equivalent fractions. It looks like I got a winner right here. Aren't both of these half? Now, if you wanted to go through the process and cross multiply all of them, by all means do it. But this is 1/2 and this is 1/2. The answer should be D. Okay. So you can do it two ways. You can reduce the fraction, see if you got it, or cross multiply. Number 2. A piece of cheese has dimensions of the rectangular prism below. And we can see those 6, 3, and 4. This thing is cut, a horizontal cut along the dotted lines that are shown here, which best describes the shape and dimensions of the top face of the slice. So basically what we're saying is we got a cross section here. If I take this off and we stare into it, what's it going to look like? This looks a lot to me like a copier paper box that we used in class. I want to know if we take the top off and I show it to you, what are the dimensions? Okay. Well, we know that this ledge is 6 right here because this one is. So we know it's 6. And this 4 is how tall it is. That doesn't factor in because it doesn't have any height now. That cross section becomes two-dimensional. It's going to be 6 by 3. A square with side lengths of 4 centimeters. No, that's not it. A rectangle with sides 6 centimeters by 3 centimeters. All right, let's go ahead and check out our other answers though. A rectangle with sides 6 by 4. This is a trap. You got to be careful here because you're going to look at that and say, "Oh, it's 6 by 4. Boom, I'm done." Okay. B, rectangle with the sides of 3 by 4. Now we didn't cut it this way. We cut it this way. So the answer is going to be B. And again, I hope I haven't cut too much of this off here. Let me try something. Adjust my thing just a little bit here. Bear with me. Yeah, that's probably a little bit better. I hope I haven't cut too much of this off. If I did, you'll just kind of have to rely on what I say and not what I wrote. Sorry about that. Number 3, a weather balloon. A weather balloon is at an elevation of 344 feet and it descends, which means it falls at a constant rate. That means it's not going real fast one minute and real slow the next. It's at a constant rate. The balloon reaches the ground in 4 minutes. Which best describes the rate at which the balloon's elevation changed? We're looking for a unit rate. We want to know, and please don't multiply this. Please don't multiply this. This is a unit rate where we're going to have distance over time. Here we have negative 344 feet. Please be careful with your negatives in the 4. Okay. So we're going to divide 344, or negative 344. We know the answer is going to be negative because a negative divided by a positive is a negative. This is 8, I believe. Yeah, 8. 32. 2, 4. And there's 6 times. So our answer is 86, but it's negative 86 feet per minute. We're talking about descension or something falling. It is going to be negative numbers. 4. Local radio station is conducting a survey to determine the favorite summer movie of teens in the city. How would the survey most likely get a random sample that is representative of the population? All right. A, asking every 5th person at a local movie theater to name his or her favorite movie. That might be a good choice. Let's hang on to that one a second. B, by asking random teens from local schools to name their favorite movie. That might be a good choice if A weren't present, but you might have a lot of people at local schools that don't even care anything about movies. So let's not eliminate that one just yet, but I think that between A and B, A is a better choice. C, by asking all the teens attending a current movie to name their favorite movie. I want to eliminate that one because truth is they may be at their favorite movie. I've seen several movies in the theater more than once because that was my favorite movie. So let's eliminate that. And D, by calling teens from around the country. This says favorite summer movie of teens in the city. You might have somebody out west or whatever who's far away from here who doesn't care anything about the movie that people in this city care about. So we're going to eliminate this one, this one. I think A is a better choice because you have people that are interested in movies and at a local movie theater. I think we should go with that one. Subtract. We've got a negative 3 minus a negative 24. Guys, we have a subtraction problem and our song doesn't work, but we can keep, change, and flip this, make it into an addition song, sing our song, and go from there. If you don't understand this concept logically, then you can use those mnemonic devices or those songs I taught you. But remember, those songs do not work for subtraction. You have to keep, change, and flip that to a positive 24. Now you've got addition and we can sing our song. Same signs, add and keep, different signs, subtract. Are these same signs, add and keep, or different signs, subtract? They're different signs, so we're going to say 24 minus 3 equals 21. Take the sign of the farthest number. Which one is farthest from 0? It's 24. The answer is going to be a positive 21. Okay. Now, another shortcut you can do. Whenever you have a minus sign, a parentheses, and another minus sign, that looks kind of like a plus sign. You can do that too. And then we do same signs, add and keep, different signs, subtract, and go from there. Now that you've got negative 3 plus 24, I want you to think of temperature the best. If you're in Green Bay, Wisconsin, you've got negative 3 degrees. There's a warm front moves in and makes the temperature rise by 24 degrees. You've got to go from negative 3 all the way up to 0 and then keep going to get to 21 degrees. Think of temperature, think of elevation, think of whatever it is that helps you understand those concepts of positive and negative numbers, because you've got to be able to master those. Okay? The total cost if I multiply, bear with me, I got to get my bearings straight here. Yes. Each binder, 24 divided by 8 equals 3. So each binder is $3. Multiplied by n, the number of binders, which would be 8, and our total cost would be 24. Okay? We don't divide the number of binders by 3 to get the total cost. Okay? We definitely don't do that. We don't divide the 192 by the total number of binders to get our total cost. We don't do that either. And we certainly don't add 16 to the number of binders to get the total cost. We multiply 3, which is the price, the unit price, times the number of binders to equal T, the total price. 7. Always debt, or almost always, is going to be represented by negative numbers. Lola owes her sister $18.50. She gives her sister back $9.75. So we're going to add that. Same signs, add and keep, different signs. We're going to subtract. We're going to say 18.50 minus 9.75. 5. Except this is 17. This is 8. 8.75. Or you could simply think through this thing logically. Okay? You can say, look, Lola owes her sister this much and she pays her back this much. So I'm going to say $18.50 minus this, and now I owe her $8.75. Why is it negative? Because she still owes her that amount of money. Debt is almost always represented by negative numbers. As a cold front moved in, the temperature dropped 3 degrees each hour for 6 hours. Negative 3 times 6 equals negative 18. That was the total temperature change after 6 hours. Negative 3 times